Okay, so we'll continue with the topic of isometric projection. The topic circles in isometric. Circles in isometric. So if this is the front view, and in this front view, if there is a circle, if there is a circle like this, then and how we represent it? We represent it by some dimension like this, and I say this is phi 30. Then what will happen is when you incline it, one of isometric positions are drawn at what? Are drawn at some inclination, 30-degree inclination. So when we incline it, what will happen? This surface. So if I try to incline it in such a way that it is inclined about this point, about this axis, you can say about this axis, okay, and this portion we are bringing close to us. So since we are bringing it, so you can consider like this is a flag, something like a flag, and that flag is moving in such a way that this portion is coming close to us. So after some period, what will happen? After some period of time, no, this will not change. This will not change. This will remain as it is. What will change is this. So if this is earlier, say 60, after some period of time, if we are rotating it will become approximately say 40. Okay, so this will become what? This will become 4040. Again, if you are turning it, then after some point of time it will become approximately this is 20. So every time when we are moving it, its dimension will change. So this we have seen in what? Projection of planes. What about this? Now how much is this right now? The circle diameter is 30. So now since this has become 60 to 40, so this will also reduce from 30 to something we don't know. Let us consider that it is increasing in such a way that now when it is increasing in such a way that this is a circle, this is a circle, okay, that same diameter 30. So here this is 30 here and it is 30 here. So is vertical dimension going to change? No, this is not going to change. This is going to remain as it is. What about this 30? This 30 is reducing. So here what will we get? Since it is moving in such a way that the vertical dimension remains the same, but the horizontal dimension changes. So this will try becoming an ellipse. So at some point of time, every time it will become ellipse. So it will become ellipse like this. So when this is inclined, this dimension 60 is going to reduce to 40 to 20, and if we keep inclining, at one point this dimension will become just a straight line. Okay, and this circle, this vertical dimension of circle, which is 30, which remains 30, it remains 30, and here also it remains 30. Here, somewhere here, there will be the circle here, okay, which cannot be seen. As this dimension is decreasing, this circle dimension, horizontal dimension of circle will also decrease. So this is 30, then it became 20, then it became 12, 10, 9, 8, 7, and maybe it become again 1, like this. So what I want to explain from this is the circles are seen as ellipse in isometric because we are inclining it. So they are seen as ellipse. So how do we draw this ellipse now in isometric? So there are methods which are used to draw ellipse in isometric. So whenever you have to draw circle, you will not draw it as circle, you will draw it as ellipse. See, if this is the circle, okay, if this is the circle in this box, this is the circle, and I say that the diameter of circle here is 30 mm. Okay, 30, 5, 30. Now I have to construct this into ellipse. So in order to construct this into ellipse, what will I do? Now, when we construct it into ellipse, either it can be done in three ways. See, ellipse can be drawn on this face, ellipse can be drawn on this face, and ellipse can be drawn on this face. Okay, this face. So we can draw it on three faces. You can say left, right, and top. So we'll understand the method, okay, and then we'll see how to draw in three different on three different surfaces. So this is say right side, this is the left side, and this is the top side, and this is O. Okay, the method is same for either it is to be drawn on left side, right side, or top side. The method is same. What is the method? The method is like this. What is the diameter of the circle? 30. Okay, 30. So I will construct a, a box like this. Now what is this side? This is 30, this is 30, this is 30, and this is 30. So what is this? Is this a square now? No, this is not a square. So what will we call this as now? Anyone?
Rhombus.
Yes, it
Rhombus.
is a rhombus. Correct. It is a rhombus. Okay. Now the rhombus will have two diagonal. One is this longer diagonal, and second is this smaller diagonal. Okay. If you draw it like this, then also you will get two diagonals. Always there will be one longer diagonal, another a smaller diagonal. Okay. So just remember that there are two diagonals, longer and smaller diagonal. So I am forget about the longer diagonal. Consider the shorter diagonal which starts from A, B, C, D. So from any point of the shorter diagonal, there are two ends of shorter diagonal B and D. So from this B, draw a line to opposite midpoint. What we do, what we'll do, we will forget about this longer diagonal. Okay, we don't want the longer diagonal. हमको याद ही नहीं रखना है उसको. We are interested only in the shorter diagonal. Okay, so shorter diagonal is BT. Now from D and from B, from both the points, we will draw lines to the opposite midpoint, like this and like this. Is it clear to all of you? We will
Yes, sir.
construct a, yes, we will construct a rhombus. What will be the size of side of this rhombus? Side of this rhombus will be equal to diameter of the circle, and then this rhombus will have two diagonals. We are interested in the shorter diagonal. So the vertex of shorter diagonal, that is B and D, that we will consider. And from those vertex, we will draw lines to the midpoint of opposite edge. So B, what is the opposite edge to B? AD and DC. So B to midpoint of AD and B to midpoint of DC. Similarly, from this corner, again draw two diagonals. So one is this, another is this, from these two corners. Now once this is done, then we just have to construct the ellipse, and the ellipse will be drawn like this. Now for drawing ellipse, there will be one center will be this, second center point will be this. How many center points I have marked here by green? Green. Two center points marked by green, and at the same time two center points marked by red. So from red, that is, if this is the center point, B, B is the center. How many center points you can see? Four. Two are this corner of the shorter diagonal, and two are this formed by the intersection of these lines. So with B as center, so what should be the radius? You can see what should be the radius. B, this point, B, this point. So if I name this point, then this point can be, say, E and F. E and F. So we'll construct an arc from E to F like this. E to F. Then Again, which is the center now? D is the center, D. And D center, so from this point, center point D, how many lines we have drawn? One line D to G and another line D to H. Okay, so DG, DG and DH. This becomes radius, D becomes center, and we will construct again an arc by using compass. Okay, so we will draw arc like this. Okay, so we'll get these two arcs. Now I am repeating, before I explain for this green color center, I am repeating for red color center. See how we got this red color center point. It is the end points of the shorter diagonal, which is the shorter diagonal BD. End points of the shorter diagonal B and D. So these 2 points become the center. Now if B is center, then what is the radius? Radius is the two lines which are coming from B or which are drawn from B. So BE and BF, these are the two lines. So this becomes the radius, either BE or BF. So this is equal, BE and BF are equal, and you draw an arc. Center is this red color mark. Now next, this is the center D. Okay, and then D, say how many lines are going? D to G and D to H. So D to G is equal to D to H. So with this as center, again draw an arc. So in short, these all, when we consider B as center or D as center, the radius remains the same. That is, now I am taking names of some points. You can just concentrate. B E equal to B F equal to D G equal to D H. So all these are equal. So this is what? Radius. And this is what? This is center. And we have drawn arc like this. Is it clear till here?
Yes, sir.
Any doubt
Yes,
to any student till here? Okay, no doubt. Now we have to draw arc with center as this green color dots. You can see these two green color dots. Okay, so now the radius will be, you can understand now, this point to G equal to this point to E. This point to E and this point to G is the radius, and these two radius are equal, and these two radius are also equal to this point to F and this point to H. Okay, so what I will do is I will again draw arc. It will go like this, and this will come like this, and we got an ellipse now. So this is drawn by multiple color. You may not be able to clearly see an ellipse, but you will get an ellipse in this case. Now this ellipse will be drawn on which face? On this face, like this, on this face. Again, I am repeating. If you have any doubt, you get it clear. In order to draw ellipse, what will we do? We will draw a rhombus. Now, how will we draw a rhombus? If the ellipse is to be drawn on left hand side, then the rhombus will be drawn on a plane. The plane should be parallel to this surface. Okay, you can see this is parallel to this surface. If it is to be drawn on the right hand side, then you will draw a plane which is parallel to this surface. How it will be parallel to this surface? Then in that case, the plane will be like this, parallel to this surface. And if you have to draw it on top of the this box, then your plane will be parallel to the top surface. How it will be parallel to top surface? It will be parallel to top surface like this. So this one is parallel to this. Now since we have to draw ellipse on this face, we have drawn it like this. This surface ABCD is parallel to this particular plane. Now after we draw this, we need to find shorter diagonal. So longer diagonal, we don't want longer diagonal. Okay, we want shorter diagonal. Sometimes student may remember that sir has told to use longer diagonal, and they will do the entire thing with longer diagonal, and they will end up with something different. Okay, so I have specifically written here, forget, bhul jao isko, longer diagonal. Just remember the shorter diagonal. Now when we get the shorter diagonal BD, so this point B is one center, this point D is another center. So with these 2 points as center, and what will we do? We will mark points on the midpoints of AB, BC, CD, and DA. What are the endpoints? Midpoints G, H, F, E. So we got 4 midpoints. Now we got 2 corners. So with this point as center, B, and radius is equal to the 2 lines which are passing from B. So which are the 2 lines passing from the B, BE, and BF. Okay, so these are the 2 lines passing from B. So with B as center, draw an arc. Then with D as center, again the shorter diagonal, D as center, DG, DH. So DG is equal to DH, and that is also equal to BE is equal to BF. So with DS point as center, draw an arc. Okay, so you got an arc and another arc. So this red portion ellipse is done. Now closing portion of for the ellipse, that is this and this. So for that, what will we do? We get this 2 center points here, which are green color center points. So with this green color point as the center, and then this as the radius, this point as the radius. So you can, if I name it something, then it can be say P and Q. So for that green color, I can say PG is equal to PE equal to QF equal to QH. So this is how you will draw an ellipse. Similarly, if you want to draw it on the other side, on this side, I will quickly tell it to you now. For drawing it on that side, what will we do? We'll draw like this. Okay, so now we are not interested in longer diagonal, we are interested in the shorter diagonal only. So which one is giving shorter diagonal? Shorter diagonal is given by this point and this point. Midpoints 1, 2, 3, 4. And now we'll draw lines. So from this to this, from this to this, and from this to this, and from this to this. Now let us construct ellipse. So with this point as center, this is one portion of ellipse. With this point as center, another portion of ellipse. Then with this point as center, the third portion of the ellipse, and with this intersection as center, another point of ellipse, and the ellipse is done. And if you want to do it for the top surface, then what it will be? It will be parallel to what? It will be parallel to the top surface. So parallel to this, so all both of this will be 30 degree, 30 degree. Okay, this will be 30 degree, and this will also be 30 degree. Correct? Now how to draw this? Again, ignore the longer diagonal. So ignore the longer diagonal. So consider the shorter diagonal is this and this midpoints 1, 2, 3, 4. From shorter diagonal to this and from shorter diagonal to this. Again from this corner of shorter diagonal and like this. Now how many centers we have? We have this point as center and we have this point as center. So with this as center, draw an arc, and with this point as center, draw another arc. Similarly, we have these 2 centers and complete this ellipse. Complete the ellipse like this. Okay, so is it clear to you? Any questions? Anything not understood?
Yes,
Any
sir.
question? Okay. So this is
सर
the,
मालूम कैसे पड़ेगा किस पे बनाना है सर,
वो तो
लेफ्ट पे
ऑब्जेक्ट
राइट
में
पे
पता
कि टॉप?
चलेगा ना, वो तो ऑब्जेक्ट को देख के पता चलेगा ना, वो देखते हैं ऑब्जेक्ट में. हाँ.
सर ये सिर्फ रोम्बस का था ना सर?
रोम्बस का था मतलब
फॉर अ रोम्बस फिगर राइट, और एनी फिगर?
नहीं, ये तो सर्कल को कन्वर्ट करना है हमको, और उसके लिए रोम्बस बनाना है. तो प्रोसीजर इन्वॉल्व्स ड्राइंग अ रोम्बस फॉर इलिप्स. ये रोम्बस के लिए नहीं, ये सिर्फ सर्कल को, अभी मैंने यहाँ पे एक्सप्लेन किया ना सर्कल का इलिप्स कैसे दिखता है. तो सर्कल को ड्रॉ करने के लिए, इलिप्स ड्रॉ करने के लिए हमको रोम्बस मेथड यूज करना है.
ओके सर, ओके सर.
ओके. थैंक यू फॉर वॉचिंग द वीडियो। अगर आपको वीडियो अच्छा लगा है तो इसे लाइक जरूर कीजिए और अपने दोस्तों के साथ शेयर कीजिए, और ऐसी वीडियोस को देखने के लिए मेरे चैनल को सब्सक्राइब कीजिए। थैंक यू।